YouTube viewers. In this particular video, we're going to be looking at the progression of diabetes. And diabetes is a very serious disease, of which I have. And so what we're going to be doing is we're going to be simulating the data. But if I had been really motivated, I could put all of my blood glucose readings in a spreadsheet and convert it to a CSV file, and then you could have all my blood glucose readings, and who knows, I may decide to do that at some point. But diabetes is a very insidious disease, and it is progressive, and that's why you're supposed to take your blood glucose readings every day to see how the disease progresses. And the reason why is because the older you get, the more insulin resistant you become. So I'm very insulin resistant, and I've got pretty bad diabetes. And at one point, they may have to give me insulin, which I don't really want to do. But so now you know a little bit about diabetes and how serious this disease is. Then what we will do is we will track diabetes using a Python program. So if you get diabetes and you want to track it, if you've got the time to track it, then you can do that using this program. So we're going to write a program in Python to track the diabetes, and we're going to import 3 libraries to help us to execute the program. So the first library we're going to import is NumPy as NP, which is a numeric library that also creates NumPy arrays. We're going to import Pandas as PD, which is a data processing library, which also creates data frames and series. And we're going to import matplotlib.pyplot as PLT, which is a visualization library. So what we're going to do now, after we have imported our libraries, is we're going to simulate some synthetic data for tracking purposes. And so the first thing that you want to do is you want to set your seed. So when you set your seed, what happens is every time you run the program, it initializes to the same values. So you type np.random.seed, and you can put any number that you want in the brackets. And then so days equals np.arange, brackets 1,366. So you're going to simulate data for 1 year being 365. So you're going to simulate your blood glucose levels. Glucose trend equals np.linespace, brackets 120, 180, ln days, which is 365. So that's a gradual increase in glucose levels, and that's pretty true because diabetes tends to get worse as we age. And glucose noise equals np.random.normal. Normal is a normal distribution, brackets 0, 10, ln days. So you're going to have your glucose noise is going to be 0 to 10, and 10, ln days 365. So you're going to have some random fluctuations. So your blood glucose is going to be your glucose trend plus your glucose noise. And I will say they measure blood glucose differently in the UK than they do in the US. In the UK, like I measured my blood glucose this morning, and I think it was 6.6 or 6.7 or something like that. And that's in full diabetic medication, and it's still high. So now we're going to simulate the HbA1c levels. HbA1c trend equals np.linespace, bracket 6, 8.5, ln days. So that's a gradual increase in HbA1c levels. HbA1c noise equals np.random.normal. Normal is a normal distribution, bracket 0, 0.2, ln days. That's your random fluctuations. And HbA1c levels equals HbA1c trend plus HbA1c noise. So now we're going to simulate the insulin sensitivity. Insulin sensitivity trend equals NP dot line space brackets 100, 50, ln days, which is 365. So you have a gradual decrease in insulin sensitivity. And insulin sensitivity noise equals np.random.normal. That's a normal distribution, bracket 0, 5, ln days. So that's 365. So you've got random fluctuations. And so insulin sensitivity equals insulin sensitivity trend plus insulin sensitivity noise. So we're going to create a data frame with all of this information using pandas. Diabetes data equals pd.dataframe brackets, curly brackets, day, days, blood glucose, blood glucose, HbA1c, HbA1c levels, insulin sensitivity, insulin sensitivity, curly brackets. So now we're going to plot the diabetes progression. So plt.figure, figure size brackets 6, 4. So we're going to graph our blood glucose levels. So plt.subplot brackets 3, 1, 1. plt.plot brackets diabetes data square brackets day, diabetes data square brackets blood glucose, level equals blood glucose milligrams per deciliter, color equals red. plt.title diabetes progression blood glucose. plt.ylabel is blood glucose milligrams per deciliter. plt.grid is true, and plt.legend. Now we're going to plot our HbA1c levels. plt.subplot brackets 3, 1, 2 brackets. plt.plot brackets diabetes data square brackets day, diabetes data square brackets HbA1c, label equals HbA1c percentage, color equals blue. And then you got plt.title diabetes progression HbA1c levels. plt.ylabel is HbA1c. plt.grid is true, and plt.legend, you get a legend. So now we're going to check insulin sensitivity. plt.subplot brackets 3, 1, 3. plt.plot brackets diabetes data square brackets day, diabetes data square brackets insulin sensitivity, label equals insulin sensitivity AU, color equals green. The title, the plt.title is diabetes progression insulin sensitivity. And then plt.x label is day, plt.y label is sensitivity AU, plt.grid is true, plt.legend. And then we adjust the layout and show the plot. So plt.tight layout, and then we show it. So this is what we've come up with. We've come up with a diabetes progression of blood glucose, HbA1c levels, and insulin sensitivity. So you can see that over the course of a year, the blood glucose is increasing, and you can see that over the course of a year, the HbA1c levels is increasing, and over the course of a year, insulin sensitivity is decreasing. And that's because as we age, we become more insulin resistant as we age. And as I said, the only thing that I would be able to check would be my blood glucose levels, because I have a blood glucose meter at home, and I get the Lancets. Let me see, the Lancets and the strips on prescription, and I don't have to pay for prescriptions anymore. But so that's all I could do would be the blood glucose. I wouldn't be able to do the HbA1c levels and I wouldn't be able to do the insulin sensitivity. But that's it. If you've got the equipment and you want to monitor your blood glucose level, then this is how you can monitor your blood glucose level over the course of a year. And if I ever have some free time, which I don't think is very likely, I can sit there and go through my blood glucose levels over the course of a year and monitor those levels so you can see them. So yeah, if I have some free time, then certainly I'll do that. So that completes this video, and I will be making a new video on another statistical subject, and I hope that you decide to watch it.